Welcome to this course on cloud computing. I'm Sarah, and I will be your instructor for this first chapter. In 2018, The Register, a British technology news and opinion website, published an article titled "Amazon is at this point a money-printing cloud machine with a grocery store by the parking lot." This implies that Amazon's multi-billion e-commerce activities are eclipsed by their cloud offering, giving you an indication of the rising importance of the cloud. Cloud computing has rapidly developed throughout the years and is slated to grow even further. According to Gartner, global spending on cloud services will reach a whopping $266 billion this year, which is about the gross domestic product of Finland or Vietnam. But what is cloud computing exactly? Let's start with a definition. Cloud computing is the delivery of technology services, including compute, storage, databases, networking, software, and many more, over the internet with pay-as-you-go pricing. So, rather than owning your own computing infrastructure or data centers, you can rent access to these different services from a cloud service provider, like Amazon AWS, Microsoft Azure, or Google Cloud Platform. Let's look at an example to get a better understanding of how it works. Imagine you're a company, and you have a website. Let's use Datacamp as an example. Learners can navigate to the Datacamp website to take a course. Datacamp periodically runs free weeks, during which learners can access all content for free. This attracts more learners than usual to the website. More learners is great, but with increased traffic can come problems. If not set up correctly, our equipment can't keep up with the demand, and the service slows down, which might cause learners to stop using Datacamp. This is obviously not what we want. But what can we do to make sure that this doesn't happen? We first need to understand how you can host a website. One way is to buy a server and host the website on that server. Think of a server as a very powerful computer that you are able to access. Typically, they don't come with a monitor, but you connect into them remotely. Your server will be located on the premises of the organization. When your success kicks in, and more people start using the website, you'll have to buy or rent new servers to handle that traffic without slowing down the website. It will take time to set them up, and will cost a lot of money. Even though you won't need these servers all the time, only during the free week in the example, you still pay for them all the time. The other option is to use cloud computing. This time, you put your website on a cloud server, similar to how you put it on a dedicated server before. Once again, you can access this server remotely. You'll now have access to computing power instantly when you need it. As more people start visiting your website, and you need more power to scale up, you can access more computing power in the cloud as you need on demand. If your website traffic comes back down, you can easily release those servers back to the cloud. Billing works similar to how you pay for electricity or gas. When you use the cloud service, the meter starts running, and when you're done, you turn it off and the meter stops. Let's contrast these two approaches. Cloud is more scalable, as you can easily add or release cloud resources. Compared to on-premise, it also has a fast setup speed. Lastly, the billing is more flexible in the cloud since you only pay for what you use. However, an important note to make is that the best approach depends on your use case. There are situations in which an on-premise server is cheaper or possibly more secure. More on that in the next lesson. You can do more with the cloud than host a website on a server. You could store, backup, and recover data, create cloud-native applications, stream audio and video, deliver software on demand, analyze data, embed artificial intelligence models, and much more. Many companies make use of cloud technologies to grow their business and meet their goals. Let's see how well you understand cloud computing. Time for exercises! Now that you know what cloud computing is, let's look at what makes it so powerful. Remember this slide? Cloud providers offer many different services. The three basic ones are compute, storage, and databases. Compute objects are the brains that will process your workload, like the server in the web hosting example from before. Storage resources help you save and store data, like images and files. Databases store more structured sets of data. Think of data organized in tables. You can combine these three and other services to build different types of cloud solutions. So what makes these cloud solutions so powerful? There are many benefits related to cloud computing. We are going to look at some characteristics: virtualization, scalability, cost, speed, performance, growth, reliability, and security. Virtualization is a fundamental technology that powers cloud computing. It splits a physical server into several virtual servers, each running their own independent operating system. Not only will this allow a more efficient use of the physical resources available, it also abstracts the physical layer from the virtualized machine, making it more portable and easier to manage in a cloud environment. This reduces the need for physical machines and maximizes the output of individual servers, allowing cloud providers to operate on economies of scale. With cloud computing, you can easily add and remove resources as you need them. Imagine you are an e-commerce site. During peak times like Black Friday, you will need to have enough resources available to handle the increased traffic. The scalability of the cloud makes it easy for you to do so. There are two types of scaling: vertical scale or powerful server, for example. With horizontal scaling, you're simply increasing the number of instances you're using, sharing the workload across multiple devices. With many cloud services, you only pay for what you use. If your instance is running for 3 hours before you shut it down, then you only pay for those 3 hours that you are using it. On top of that, you don't have any capital expenses of buying hardware and software and managing your on-site infrastructure. Just like buying a house can sometimes be cheaper than renting one, an on-premise solution can be more cost-efficient than renting from the cloud. If the resources you need are clear and stable over time, an on-premise data center might be cheaper in the long term. The best solution depends on the use case. Note that there are cloud services with other payment models as well. The cloud makes resources available to you almost immediately when you ask for them. This is called on-demand resourcing. There is a fast setup time, and you can deploy technology services in a matter of minutes. No waiting around for hardware to be ordered, installed, cabled, and configured before using it. An organization's IT operations and equipment are housed in a facility called a data center. A single on-premise data center, in most cases, cannot compete with the worldwide network of data centers provided by cloud providers. They regularly upgrade to the latest generation of fast and efficient computing hardware. With the cloud, you can grow using a wide range of resources and services. Because of the on-demand resourcing, growth constraints are significantly reduced. Additionally, you can expand to new geographic regions and deploy globally in minutes. Most cloud providers allow you to provision resources across their global network. Cloud computing ensures the durability and availability of your data and services. This is possible because the data is purposely replicated at multiple redundant data centers in the cloud provider's network. If one data center is impacted by, for example, a natural disaster, you don't need to worry, as the data is still available elsewhere. It's important for companies to make sure that all data is securely stored or managed. When choosing for a cloud solution, you are trusting an external party to keep your data secure. Whenever an outside party is trusted with your company data, you run the risk of unauthorized personnel accessing it. Cloud security controls are particularly risky for businesses in highly regulated sectors, like healthcare, government, or finance organizations. This is why an on-premise solution might be preferred. Nevertheless, more and more cloud providers are offering services that are aligned with these regulations and guarantee both physical and virtual security of their data centers. Time for exercises. In this video, we'll talk about the different cloud service models. In a way, cloud computing is like ride-sharing. Just like companies don't have to buy IT infrastructure but can rent it from a cloud provider, you don't have to buy a car but can rent one by using a ride-sharing app like Uber or Lyft. This means you don't need to pay any of the maintenance or fuel costs that come with owning a car. You simply pay for what you use when you use it. The ride-sharing company, in their turn, can benefit from significant economies of scale by delivering the same services to a wide range of customers. There are also other alternatives to owning a car, depending on the level of control you want. You could rent a car, use a ride-sharing app, or use public transport. As mentioned before, owning a car is similar to the on-premise approach. You are responsible for everything: the car, maintenance, insurance, cleaning, parking, fuel, driving, and finding a route. The first type of cloud service model is called Infrastructure as a Service, or IaaS, which is like renting a car. The vendor supplies the infrastructure, meaning the car and everything that goes with it. You're still responsible for parking, fuel, driving, and the route. The next model is called Platform as a Service, or PaaS. This time, the running costs are outsourced as well. You still have the control over the route you want to take though. The final model is called Software as a Service, or SaaS. In this case, you leave everything to the vendor. A bus will do this for you. Everything is taken care of, but there is also less flexibility. We can translate this diagram to a similar one for cloud computing. With Infrastructure as a Service, you rent the fundamental building blocks of computing: networking, storage, and physical or virtual servers. Platform as a Service is the next layer up. As well as the underlying infrastructure, this will include the tools and software that developers need to build applications on top of. That could include operating systems, middleware, and runtime. With Software as a Service, the underlying hardware and operating system is irrelevant to the end user, who will access the service via a web browser or app. Let's summarize. IaaS gives users cloud-based alternatives to on-premise infrastructure. Its main advantage is that it provides scalable cloud-based alternatives to expensive on-premise infrastructure. The users of IaaS solutions are usually system admins, and an example is using a cloud server from a cloud provider. PaaS provides hardware and software tools over the internet that people can use to develop applications. The big advantage is that developers don't need to start from scratch when creating applications, saving a lot of time on writing extensive code. As for its users, PaaS is tailored to developers. In case of PaaS, you can just focus on developing web and logic apps using a service for deploying and scaling web applications like Google App Engine, Windows Azure, or AWS Elastic Beanstalk. Lastly, SaaS makes software available to users over the internet, usually for a monthly subscription fee. This means there's no need to install software on your computer, since everything is available over the internet, accessible from any device. SaaS is used by the end customers, and examples of SaaS include internet applications like Google G Suite, Microsoft Office 365, and Dropbox. Most businesses use a combination of IaaS, PaaS, and SaaS. We can represent the three main cloud service models in a pyramid. As we move up, the level of abstraction increases, and the level of control goes down. Abstraction is the amount of complexity. The higher the level, the less detail. The highest level of abstraction is the entire system. The next level would be a handful of components, and so on. More abstraction goes together with less control, so you'll have to see what is most appropriate for your use case. Another service model that is becoming more important is FaaS, Function as a Service. FaaS is a variation on SaaS, except that now you're only concerned with a single function or part of the software. For example, you can run identity authentication or payment transactions. FaaS often uses a billing model called serverless. This is slightly misleading because the computations are still run on a server. What it means is that you pay for the service rather than paying to rent servers. There are many other service models as well. More and more functionality is being abstracted away from the end user and offered as a cloud service package. Examples include HaaS, SaaS, DBaaS, DRaaS, NaaS, etc. The term used to denote this phenomena is XaaS, or anything as a service. It refers to all the services in a cloud that customers can order over the internet. Let's practice!